Hi everyone, I'm Alex Heath, Strategic Advisor for ValOre Metals Corp. A lot of you are aware that we're focused on advancing the Pedra Branca PGE project in northeastern Brazil, a project that hosts over 1 million ounces of PGEs. What some of you may not know is that we also hold a very large and strategic uranium asset in our portfolio, the Angilak uranium project in Nunavut. Angilak is a district-scale opportunity which has had over $55 million spent on the project to date and has an existing 43 million pound U3O8 resource, which is in fact the highest grade uranium resource outside of the Athabasca. We've recently seen significant curtailments of uranium production from some of the world's largest uranium producers in response to the escalating COVID-19 crisis, which is positively impacting the uranium price. However, the price of uranium has been increasing since 2016 low of $17 and is now trading over $27. It's a developing story and one we'll definitely be following closely as it has significant implications for our Angilak uranium project. I'm joined today by ValOre geologist Colin Smith, head of new project review, to talk about Angilak and provide more details on the highlights of this significant uranium project. Colin.
Thanks, Alex, and hello, everyone. Yes, while our primary focus at the moment is progressing the PGE project in Brazil, Pedra Branca, we do have a world-class uranium asset in Nunavut territory. It's a district-scale exploration opportunity. In terms of size, it exceeds 100,000 hectares in scale. And to give you a little perspective on that, I'm just going to share my screen with you so we can walk through a few slides, both on the resource estimate and the exploration methodology. So that is the land package there. Again, it's over 100,000 hectares in size. And what you're seeing here is the Angilak Basin. That's geologically significant in terms of this being an unconformity type uranium system. And the NI 43-101 resource, the LAC 50 trend, is illustrated here in the yellow and red polygons. So one thing to bear in mind is that Angilak is a very explorable terrain. Much like Pedra Branca, ValOre has been able to distill a very proven and effective exploration methodology. And that's enabled us to grow our 43-101 resource at Angilak by 200% in just 3 years of drilling. So that's obviously bodes well for future exploration and future growth to the resource, because there's a huge amount of exploration potential both close to the existing resource and abroad throughout the property area. So before talking about the exploration methodology, let's just spend one slide on the LAC 50 trend resource. Okay, so here is the resource, the LAC 50 trend. The images on the left-hand side are 3D oblique long sections of the resource solid. The warmer the color, the higher the grade. As Alex mentioned before, this is a very high-grade uranium system and actually ranks as one of the highest grade resources on a global basis, and the highest grade uranium resource outside of the Athabasca Basin in Saskatchewan. Geologically speaking, the deposit model is an unconformity style uranium deposit. This is a globally explored geologic relationship that hosts most of the world's tier 1 uranium deposits and mines. Now, in terms of potential for resource growth, the LAC 50 is well endowed on that front, and I'll elaborate on that in a few slides, but there's a lot of potential both close to the resource and abroad throughout the project area, with drill confirmed uranium intercepts, extremely high grade samples at surface, and broad soil anomalies, which again we'll go into in a few slides here. Last but not least, I will mention just the metallurgical and beneficiation and recovery testing that ValOre conducted in 2014. Very favorable results. Specifically, the beneficiation recovered nearly 97% of the uranium with a 50% mass pull. And the alkaline leaching extracted approximately 95% of the uranium in only 48 hours, producing a final yellow cake product, which was 70% pure and very low impurity levels, much less than what would be penalized in smelters. So obviously these are very favorable results from the metallurgy and beneficiation side. And why don't we take the opportunity now to go through the exploration methodology. Okay, so let's now talk about our exploration methodology. and the logical path forward to finding a lot more uranium at Angilak. The next 4 slides, we'll walk through our proven and effective tactic from an exploration standpoint at Angilak, which again has helped us really grow this resource very quickly. So what you're seeing here in slide 1 is on the right-hand side a sort of 3D schematic of these uranium structures, uranium-bearing structures. And on the left, you'll see the progressive panels of exploration data which we acquire and coalesce to eventually a drill stage. How do you explore such a large land package? You know, geophysics is a natural first step. Specifically in the case of Angilak and these uranium-rich structures, VLF-EM geophysics, or very low frequency electromagnetics, effectively delineates these conductive structures property-wide. So you're getting a very high response EM signature, as you're seeing in these pink lineaments here at surface. And these are essentially what you're seeing in section here, these uranium-rich structures that come essentially right to surface and either outcrop or covered by very little superficial cover. And they occur in the geophysical imagery as these really hot pink lines. Those are very prospective structures for us. Oftentimes they host uranium mineralization, and these are seen property-wide. So how do we further vet these targets? Well, the next step is geochemistry. So I'll take you through that here. Okay, so once a prospective regional corridor has been discovered, and again, these are big in scale. They're multiple kilometers in strike. The LAC 50 trend is close to 15 kilometers. So these are large structures. How do you vet them? How do you distinguish which ones are uraniferous, which ones are not? And of the ones that are uraniferous, how do you further conceal where we should be drilling or where we should be doing further work? Well, soil geochemistry has proven a very effective next step in determining where the mineralization sits. Because these structures come right to surface, they really light up in soils. So what we do is we plan orthogonal lines that go across the structure at perpendicular angles, and it's uranium in soils and or enzyme leach uranium. And again, if there's uranium in that structure, they will show up in the soils. So as you see on this schematic here, we have determined through the use of VLF-EM that there's a strong conductor here, which is, as mentioned before, prospective for potential uranium. So to further test that, we planned orthogonal soil sample and or enzyme leach geochemical lines across that structure. And through that sampling, we are able to determine what parts of the structure are uranium bearing. So what's the next step? Well, let's have a look. Okay, so we have established that we have regional scale conductive structures here through the use of VLF-EM geophysics. We have overlain these geophysical anomalies with orthogonal soil and enzyme leach lines to further delineate where the uranium mineralization is sitting. The next step is testing with the drill bit. As you see in the cross section here, these are fairly planar, linear structures. So as long as you know the orientation of these structures, really it's just a matter of stepping down dip and drilling these things at depth. Typically what we've done at Angilak is drill in fence arrangements from either 2 to 4 holes on a fence, and this allows us to pierce the structure at a various number of depths and give us an extent on how deep these structures actually go. And this is what enabled us to create and develop the 43101 resource on the LAC 50 trend, which you see in the slide here. Again, the panels on the left-hand side here represent the VLF-EM on top. This is what the uranium in soils anomalies look like. And again, you see hot spots that are localized along the trend of the conductive signature. Follow that up with drilling, and there you have your 43 million pounds of U3O8 at globally ranking high grades. So that's the generalized exploration methodology. As I said before, the exploration potential is really exceptional property-wide, and the potential to expand the resource, the 43101 resource of the LAC 50 trend, is exceptional, and I'll show you what I mean by that in this next slide. So we're looking at the same panel of 3 images that we saw before. Again, the VLF-EM on top. Here's your conductive trend. Here's uranium, your gridded uranium in soils anomalies. So you're seeing these little hot spots of uranium throughout that belt. And below here, the purple is the 43101 resource. And what you're seeing in red at Pulse, Hot, ML, Spark, Blaze, Flare, those are all uranium targets that have been drilled. They've hit uranium, and as you see, the hit ratio is exceptional. 6 of 7 holes here, 4 of 7, 6 of 11, extremely high grades, well over 1% of U3O8. These are exceptional targets that really just require additional drilling, and with additional drilling, we could see those move into the inferred 43101 category very quickly. Back to you, Alex.
Thanks, Colin. Excellent summary. Angilak is a strategic uranium asset with great potential, which at one point supported a market cap of $90 million for the company. And although we will not be conducting any exploration on the project in 2020, it's a tremendous asset as uranium prices continue to climb. If anybody has questions about Angilak or want to learn more about the company, please visit our website at valoremetals.com or send us an email at contact@valoremetals.com. Thanks for watching.